Hello everyone, this is Steve. This video is part of my physics assessment quiz on chapter 11, which deals with the angular momentum and torque. And today in this video, I'm going to solve a problem connected to angular momentum and torque. Here in this question, I've been given a lump of clay of mass 0.07 kg, which travels at speed of 20 meters per second, and which strikes and sticks to a long thin rod of mass 1.0 kg, which has a length of 0.2 meter, which is shown in the free body diagram over here. And the rod was at rest before the clay hits it. So, and the rod is freely to turn on a nearly frictionless pivot as given in the question. And in this question, we have been given the moment of inertia about the center of a long thin rod of mass m and length l, which has the value of capital M L squared over 12. So, in order to solve this question, we use the angular momentum principle. So, the angular momentum principle states that the final angular momentum is equal to the sum of the initial angular momentum plus the product of net torque and the change in time. So we pick our system in this question to be rod and clay, but not the earth. And the system here experiences a force at the pivot point when clay hits the rod. And we will measure the angular momentum and net force from the pivot. So we have the torque due to this force 0, since we know that the torque can be calculated by the product of the force and its distance from the center of the pivot. So this gives me the value of 0. So due to which, when we substitute the net torque in our equation here, we'll get that final angular momentum is equal to the initial angular momentum. And now the initial angular momentum is the magnitude is the product of the the product of the momentum times the distance from the center of the axis of rotation. And we have the distance here 0.15 meter, and since p is momentum, which is mass times the velocity, and the clay of lump has the mass of 0.08 kg and is travels at speed of 20 meters per second, I have the initial angular momentum of 0.24 kg square per second. Now, the final angular momentum is when the clay of lump sticks to the rod. Now we have two things here. The final angular momentum is the sum of the moment of inertia of the clay and the moment of inertia of rod times the angular velocity here. So the moment of inertia of the clay can be found out by the formula mr square, where m is the mass and r is the distance here, r square. And we have been given the moment of inertia of the rod from the question to be ml squared over 12, where l is the length, m is the mass of the rod. And so by substituting all the values that we have been given in the question, we get a value of 4.908 to the power minus 3 kg square times the angular velocity. But here, now this value is equal to the initial angular momentum. And so when we equate those two, final and initial angular momentum, we get the value of angular velocity to be 48.9 radian per second. So this is the angular speed of the object just after the impact. I hope you like this video, and I hope this will